Hi, today we are going to look at one more related rates problem, and this is problem number 1 under the more related rates section. We have a man walking due north 2 feet per second. A minute later, the woman walks due south at 3 feet per second. They are 60 feet apart, due east from where they start. So we end up a situation like this. Okay, and we want to find the rate of change of the distance between them. This is what we're looking for. And so I'm going to call that y. We need to find dy dt. Now, the way the picture is right now, it is kind of difficult to work with. Instead, what we will do is kind of shift things. If I shift this over on this side and consider the person walking here, they're still walking at 3 feet per second. This distance is still 60. But now by doing this, I've now created a large right triangle. And if we think of this entire distance here as x, then I am given dx dt, because dx dt would be, because they're walking completely opposite of each other, dx dt is going to be 5 feet per second. If they're walking in the same direction, exactly the same direction, then you would subtract the two rates. If they're walking at some angle between them other than, either directly opposite or the same, then you have to use physics. So you'll do that in physics. You have to use math, but in physics. Anyway, you'll see that later. So this is what we have. And because now I have a right triangle, I have a nice formula. X squared plus 60 squared, if I can write it correctly, is equal to y squared. Pythagorean theorem. My snapshot value, the derivative 2x dx dt is equal to 2y dy dt, and I can get rid of these 2's. And so then we can use the snapshot value. The snapshot value was 2 minutes after the woman begins walking. So we need to break this apart for the man. He walks 3 minutes total. He walks at a rate of 2 feet per second. And since these units are not the same, this is one time when writing units is useful. There are 60 seconds in a minute, and the units reduce out, and all we're left with is 360 feet. For the woman, she walks 2 minutes at a rate of 3 feet per second. Again, 60 seconds per minute. And voila, we still end up with 360 feet. She also goes 360 feet. So they both end up walking the same distance. She just does it in a minute less time. Which means that the total value for x is 720. Okay? Which means that I get my right triangle, where this is 720. This value is 60, and we still need to find the value for y. So y squared is equal to 60 squared plus 720 squared. If I had a calculator on me, which I don't, we could calculate this out. I'm going to do this old school. y squared then is going to be 60 squared plus 720. Well, 6 times 12 is 72. So 60 times 12 is 720. And so this then becomes 60 squared plus 60 squared times 12 squared. And I can factor out. And I'm left with 1 plus 144, which means that y is equal to 60 square roots of 145. And now we will use these values in this related rates equation. I get x, we said, was 720. dx dt, we said, was 5. Y, I came up with 60 square root of 145. dy dt is what I'm looking for, which means dy dt is equal to 720 times 5 over 60 square root of 145, or reducing this, this becomes 60 over the square root of 145 feet per second. I do not care. In fact, more than likely you are going to use a calculator. That's not a problem. I just don't have one on me, so I'll do it this way.